In example 107, we're going to sort of develop our approach to compound interest situations. So when interest is compounded periodically, what we do is sort of split up that annual interest rate over equal, smaller interest rates for each compounding period. Here in example 107, we've got a 12% annual interest rate, so we know that R is 0.12, and it's compounded monthly. And what this tells us, since it's a 12% annual, compounded monthly 12 times per year, that the compounding or the interest rate per month is 0.12 over 12, or 0.01. So each month this account will earn 1%. That's added to the principal, and then at the next month another 1% is compounded, is calculated, and added to that new principal. Sort of a bit of a snowball effect. So we're going to try to figure out how much do we have at the end of the first, second, and third months if we invest $100. So P is $100. And we're going to sort of build this up by taking a simple interest approach. So at the end of month 1, let's see how much we've got. Well, we've got definitely the $100 that we had for principal that we put into the account, plus 1% interest for that month. $1% interest on that $100. And I'm going to sort of rewrite this in a way that's going to seem a little bit odd at first, but it'll help us sort of recognize a pattern emerging. So we'll notice that rather than just sort of calculate and get a total here, just notice that both of these terms that we're adding have a factor of 100. So I'm going to take that factor out. In this first term that we have, the 100 is just being multiplied by 1. And in the second term, it's being multiplied by 0.01. And so we could write this as 100 times 1.01. And I'm going to sort of leave it written like that. Over here on the end, I'll just figure out what is the total amount that we have. 100 times 0.01 is $101. For the end of month 2, now we're starting with the $101. Now I'm going to use this expression here at the end of this line rather than 101. It's going to be a little bit more convenient for our calculations. So at the end of month 2, we've got what we started out with at the beginning of that month, 100 times 1.01, and then we've earned 1% interest on that amount. So 0.01 times 100 times 1.01. And here we have something similar going on that we saw at the end of month 1. We have 1.01 as a common factor. In the first term, it's being just multiplied by 1, and in the second term, it's being multiplied by 0.01. So I'm going to factor that out. In the first term, multiplied by 1, and the second term, multiplied by 0.01. And this gives us 100 times 1.01. And then this factor here is also 1.01. So we have two factors of 1.01. So I'm going to write that as 1.01 squared. And we can get a figure for the actual dollar amount that this adds up to. $102.01. And now let's look at what's happening at the end of month 3. And again, like we did in the last month, I'm going to start off with this expression for the amount at the end of month 2. So we've got definitely what we had at the end of that month plus the interest accrued on this amount, which is 1%. And at this point, it probably comes as no surprise that we can observe we have a common factor. We've got the 100 times 1.01 squared as a factor in both of these terms. We're going to pull that out. In the first term, it's being multiplied by 1. In the second term, it's being multiplied by 0.01. And again, what we have in these parentheses on the right here, this is equal to 1.01. So we can write this expression as 100 times 1.01 cubed. And now we can use our calculator to get a dollar figure. $103.03 if we round to the nearest penny. So you might sort of see this pattern emerging looking at these forms of our final amounts that we had at the ends of months 1, 2, and 3. And just to sort of drive the point home, in the first month, at the end of month 1 up here, this is 100 times 1.01, or 1.01 to the first power. And we could probably take a guess as to how much we'll have at the end of month N at a particular sort of arbitrary month. Looks like, according to the pattern, the amount we should have at the end of month N would be 100 times 1.01 to the n power. And that's exactly what we're going to find when you take a look at the theorem on the next page. You can figure out in a compound interest situation, you're going to be using this principal amount, and then inside you're going to have 1 plus, and this would be the interest per compounding period. All raised to the n power, where n is the number of compounding periods.